Okay, you guys, there was a question about error bars and a review of how to interpret them. This is a very simple hand-drawn graph of the data collected in a study that was done testing the effect of light on seedling height. So if we just take a seed and watch it germinate, is it going to germinate better in the light or the dark? The key to understanding error bars is that they're based on the standard error of the mean. And standard error of the mean is sometimes written like this. But what that means is it's a statistical test at saying how good is the mean, oh no, which is the same thing as an average, at representing oh, this went out of focus. There we go. At representing what actually happened, like the data. More on that in a second, because I'll give you an example of how sometimes the mean doesn't actually represent what happened. And so sometimes these error bars are called confidence intervals because they show how confident we can be that the mean is right here for the dark and the mean is right here for the light, plants in the dark, plants in the light. So confidence intervals, error bars, or sometimes they're called a measure of uncertainty. And so a typical question would be, like on an FRQ, they would say, based on the data in the graph, does light influence seedling height? And the answer to that would be yes. Not because the light is higher than the dark, but because the error bars, or the measurement of uncertainty in these two data sets, as a reflection of the quality of the mean, the error bars don't overlap, okay? So overlapping error bars would signify that there was so much error in but error in the data set that ended up producing the mean. And those overlapping error bars would really create an insignificant difference between those two data points. So up here I have another example. If we're looking at mean seedling height and groups 1 and groups 2, you can see that in data set 1 and data set 2, we have an average of 12 centimeters. For both. So in other words, if the average is the same, can we say that they're statistically similar, or can we say that the error is too great to demonstrate their statistical reliability? Another way of explaining this, I usually say, just because this makes sense to most people, so let's say there's 24 students. If 12 of the students are exactly 4 feet tall and 12 of the students are exactly 6 feet tall, the mean height in the classroom is 5 feet. This mean would have a high degree of error associated with it. Why? Because 5 feet doesn't really represent anybody in the classroom. In other words, having 12 people at 4 feet, 12 people at 6 feet, and reporting the mean as 5 feet would carry a wide range of error or uncertainty. And you don't have to know how to calculate the standard error of the mean, but in a graph, you just have to know how to interpret it. So because what we have here are the same averages, but different standard errors, here we can see there's more uncertainty in data group 1 because there's a wide range, a large deviation from the mean, or a greater spread. 9 and 15 aren't like 12 at all, just like 4 and 6 aren't like 5. So while the average is the same in both data sets, there's much less uncertainty in data set 2. Okay, so if we were looking at these would be overlapping error bars. we'd say that the confidence that we have that data set 1 performed the same as data set 2 is low because the error bar is so large and overlaps with data set 2. All right, I hope that was helpful. When we look at an actual FRQ, what we see here, and this is the one you already did, is that we've got the control, which is strain 1. We've already identified that, so go back and look at this if you need to. But the control does not overlap with strain 2, does not overlap with strain 3, does not overlap with strain 4. So when I compare these two, or these two, or these two, there's no overlap. However, with strain, sorry, this was strain 5. With strain 4, there is overlap. So we would say that the results of strain 4 are not statistically significant relative to the control. Because there was so much uncertainty in strain 4 that compared to the control, we can't really make a conclusion. By the way, uncertainty means that if this is the mean we're dealing with, which looks to be about 50% survival, it means that the actual real mean could be anywhere above or anywhere below what's the reported mean. So a longer error bar just represents more variation or uncertainty in what the true mean could be. Another thing you might notice is that there's overlap between these two. So in an FRQ, you could be asked, are the results of strain 2 statistically significant relative to the control? The answer would be yes, there's no overlap here. But a scientist might, or an FRQ featuring a scientist, right, might say, are the results statistically significant between strains 2 and 3? And you would say no. You'd say they're both significant relative independently to the control. But you can't claim that strain 2 had a higher percent survival than strain 3. Because the real mean for strain 2 could be anywhere within here, and the real mean for strain 3 could be anywhere within that error bar, and those error bars overlap. So again, we can say strain 2 survived less than the control, strain 3 survived less than the control, but strains 2 and 3 did not survive any differently in comparison to one another. Okay, so that's standard error. I may have not done this perfectly. Thank you for your patience, and I hope this helps.